proofs, everyone's favorite thing in geometry. In this video, you'll see me write 3 different proofs. Now, this video will not tell you a step-by-step process to how to solve every proof, because that just simply doesn't exist. Every proof is different, and the only way to get good at it is to just practice it. Now, I picked these 3 proofs because each of them has a different thing that seems to come up, I notice, in a lot of different proofs. So listen to my commentary and really pay attention to what I point out in each proof, because it could help you in a future proof. Now, before I go on to anything, just the one thing I want you to have in the back of your mind are the 3 things you should always look for in proofs when they're triangle proofs, and what we're doing in this particular chapter. And it's first, look for vertical angles. If you see any pair of vertical angles, you know that they're congruent, and you can immediately mark them off congruent. The second thing to look for are parallel lines. Parallel lines tell you a lot, and oftentimes when you have 2 triangles where 2 sides are parallel to each other, you can find corresponding angles or alternate interior angles that are congruent, and that'll help you with your proof. And third are triangles that share a side. If 2 triangles share the same side, then obviously the side is going to be congruent to itself. So let's do the first one. Now, in this, we want to show that triangle REC is congruent to triangle RAC. So you already have 2 sides in one triangle are congruent to 2 sides in another triangle. So if we can just prove a third side is congruent in both triangles, then we know that both those triangles are congruent by side, side, side. So first, start with the easy one. Start with what's given. So first we know that RE is congruent to segment EC. Oops, no it's not. It's congruent to segment RA because it's given. It's given that they both have 1 tick mark, meaning that RE is going to be congruent to RA. Same thing with EC. That has 2 tick marks. So that's going to be congruent to CA. And that's also given. Now, look at RC. Well, RC is shared in both triangles. So if RC is 10 inches in triangle REC, it's obviously going to be 10 inches in triangle RAC. So RC is congruent to itself. And to do that, you should write the reflexive property. Reflexive property. Now, when you think of the reflexive property, think of a reflection. When you look in the reflection, you see yourself. So saying like 1 equals 1, or x equals x, or RC equals RC is an example of the reflexive property because it's the same thing on both sides of the equation. You could also write same segment. That would be another good argument. Now, the last step, we're going to write what we wanted to prove. Triangle REC is congruent to triangle RAC, and that is RAC, and that is by side, side, side. So we always end a proof with what we want to prove. And another thing I want to point out about this proof is that how on one side I wrote each step of what I noticed, and on the right side I gave a reason. A proof is a type of deductive argument, so you have to give a reason each time. And lastly, this is the first of the 3 things that I talked about before the video, or one of the 3 things, and that's same segment. Always look if 2 triangles share a segment. If they do, mark it off as congruent in both triangles, like I did here, marking off RC with 3 tick marks. Alright, let's do another proof. In this proof, we're given that I is the midpoint of CM, and I is the midpoint of BL, and we want to show that CL is congruent to MB. So, we haven't learned this yet, but to show that 2 segments so 1 segment in one triangle is congruent to 1 segment in another triangle, I first just have to show that the 2 triangles are congruent, and then the very last step, I can say that those 2 segments are congruent by CPC/TC. And that means that congruent parts in congruent triangles are congruent. And we know that because the definition of congruent triangles are that all the sides and angles of one triangle are congruent to all the sides and angles of another triangle. So if we use a shortcut to prove that 2 triangles are congruent, we can then use CPC/TC to show that any 2 either pairs of angles or sides that correspond to each other are congruent. So it's the best to start off with the givens. So let's mark off the picture. That's another thing you should always do. So since I is the midpoint of CM, we're going to give CI 1 tick mark and IM 1 tick mark. And since I is the midpoint of BL, we're going to give BI 2 tick marks and BL or IL 2 tick marks. So let's write that in our proof. CI is congruent to IM, and that's just the definition of a midpoint. Because by definition, the midpoint is directly in the middle of the two endpoints. So the distance from one end to the middle is the same as the middle to the other end. We also know that LI is congruent to IB. And that also is the definition of a midpoint. Now, remember at the beginning of the video I said look for parallel lines, same segments or shared segments, and vertical angles. So I don't see any parallel lines that are marked off with arrows. These two triangles don't share a segment, but they both share a pair of vertical angles. So we know that angle 1 is going to equal or be congruent to angle 2 because they are vertical angles. So now I could show or say that triangle CIL is congruent to triangle MIB, Men in Black, because of side, angle, side. CI is congruent to MI, angle 1 is congruent to angle 2, and IL is congruent to BI. So by definition of side, angle, side, those two triangles are congruent. Now I could say that CL is congruent to MB because of CPCTC. Corresponding parts in congruent triangles are congruent. So since these two triangles, since I already showed that these two triangles are congruent, I know that corresponding parts, such as CL and MB, are congruent. And I know they're corresponding because CL is opposite angle 1 and BM is opposite angle 2. And angle 1 and 2 are equal to each other. Another way I know that they're corresponding is that C and L are the first and last letters of when I named triangle CIL in the congruency statement. And M and B are also the first and last letters when I named triangle MIB in the congruency statement. So that's another reason why I know they correspond. Alright, don't worry. One more proof to go. I know you want to see one more. And here we want to prove that triangles SEN is congruent to triangle NAS. So always start off with the givens. So I know that SE is parallel to AN, and that's given. Okay. And whenever you see parallel lines, look for corresponding angles or alternate interior angles. So let's extend these two parallel lines out. And this is not something that you need to do, but it's something I like to do just so you can really visualize the alternate interior angles. And hopefully if you turn your head sideways, you can see that angle 1 and angle 2 are alternate interior angles. So we know that angle 1 is congruent to angle 2 by the alternate interior angles conjecture. Alright, now I'm just going to switch up the color so you can see the other pair of parallel lines. EN is parallel to SA. And again, I know that because it's given. And from there, let's look at these parallel lines. So I'm going to extend these lines out and then extend out the transversal again. And now hopefully you could see that angle 3 is congruent to angle 4 because those are alternate interior angles. So angle 3 is congruent to angle 4 by AIA. And now, is there anything else we can point out in the two triangles that are congruent? So, pause the video for a second, look for a third thing that we can show in both triangles that are congruent, and hopefully you could finish this proof by yourself. Alright, hopefully you saw that, and you can't really see it because the I drew over them, but segment SN is congruent to itself because it's shared by both triangles. So SN is congruent to SN by the reflexive property. So now I have enough information to show that triangle SEN is congruent to triangle NAS because of the angle, side angle, triangle congruence conjecture. That's it. I hope this video was helpful and you learned a lot, and have a good one.